Good morning, students. Let me start with a thought. Imagine if every time you asked for ethanol, someone called it wood spirit, or grain alcohol, or just plain alcohol. Confusing, isn't it? Chemistry has thousands of compounds, and if we only relied on trivial names, chaos would follow. That's why chemists developed a systematic way to name compounds, the UPAC nomenclature. In this system, each compound has a unique name that reflects its structure, its bonding, and the position of its functional groups. Whether it's a simple alcohol, a phenol, or an ether, nomenclature ensures that a chemist in India, Japan, or Brazil instantly understands what molecule we are talking about. For example, wood spirit is formally methanol, carbolic acid is phenol, and anisole is methoxybenzene. So you see, nomenclature is not just a naming game, it's the very language of organic chemistry, allowing us to communicate clearly and predict reactivity. Let's begin with alcohols, specifically the monohydric ones. The first step is to find the longest carbon chain that contains the hydroxyl group, the O. Then, we number the chain from the end closest to this O because it has the highest priority. Next, we replace the terminal E of the alkene with ol. For instance, CHCHO becomes ethanol. If the O is attached to the middle carbon, as in CHCOCH, the name becomes propan-2-ol. And remember, if there are other groups like halogens or double bonds, their positions are mentioned, but the O still gets the priority number. Look at ethanol, isopropanol, and terbutanol in the diagram. Notice how the placement of the hydroxyl group changes the name and classification. A quick tip, never forget that the O group outranks even double or triple bonds when it comes to numbering. Now, what happens when there is more than one hydroxyl group? Then we use suffixes like diol for 2 and triol for 3. For example, CHCHO is called ethane 1,2-diol, commonly known as glycol. And CHO is propane 1,2,3-triol or glycerol, which you may know from cosmetics and syrups. Here's the important detail: the positions of each O must be written before the suffix. You cannot just say propanol with 3 O groups. You must specify it as propane 1,2,3-triol. The diagram shows the correct numbering for polyhydric alcohols. And here's a common mistake students make, writing something like ethanol-to-ol for glycol. That's wrong. Always use the suffix diol or triol for multiple hydroxys. Moving to phenols, these are special because the O is directly attached to an aromatic ring. The parent compound is simply called phenol. If there are substituents, their positions are indicated either by numbers or by the prefixes ortho, meta, and para. For example, 2-nitrophenol is also known as orthonitrophenol, while 4-bromophenol is para-bromophenol. Dihydric phenols are also important. Catechol has the O groups at positions 1 and 2, resorcinol at positions 1 and 3, and hydroquinone at 1 and 4. Then there's fluoroglucinol, a trihydric phenol with 3 hydroxyls. As you can see in the diagram, the placement of O groups completely changes the name and properties. Students often confuse numbering with O, M, and P notations, but remember, both systems point to the same positions. Now let's talk about ethers. Their general formula is APO-A'. The naming trick is simple. The smaller group attached to oxygen is written as an alkoxy substituent, and the larger group is considered the parent. For example, CHOCH is named methoxyethane. When an aryl group is present, we call it an aryl ether. A classic example is CHOCH, which is methoxybenzene, but commonly called anisole. Look at the diagram: diethyl ether, the famous anesthetic, and anisole. Both follow the same rule: but with different parent groups. A quick warning here, students often stick to trivial names like ethyl methyl ether. But for exams, always write the systematic name, methoxythane. Let's solve an example step by step. First, CH3CHCHOH. The hydroxyl is on the end carbon, so it's a primary alcohol named propan-1-ol. Second, CHCOH. The O is attached to a carbon bonded to 3 other carbons. That makes it a tertiary alcohol named 2-methylpropan-2-ol. Third, CH with 2 hydroxyl groups at positions 1 and 4. That's 1,4-dihydroxybenzene, also known as hydroquinone. And finally, CHOCH. That's an ether named methoxybenzene or ranitol in trivial terms. The method is simple. Identify the functional group, assign priority, number carefully, and apply the suffix or prefix rule. Remember, always take top priority above unsaturation and halogens. Before we wrap up, let's see why nomenclature is so important in real life. Ethanol isn't just a drink, it's a fuel, disinfectant, and industrial feedstock. Phenol is an antiseptic and the starting point for bakelite plastic. Anisole is a solvent in dyes and perfumes. In patents, pharmaceuticals, and chemical industries, using the correct UPAC name prevents costly mistakes. And in your exams, mastering nomenclature ensures you never lose marks on the basics of mechanisms and conversions. So, to summarize, nomenclature is the grammar of organic chemistry. Without it, we couldn't describe, compare, or study the countless molecules around us. I hope this session gave you clarity on naming alcohols, phenols, and ethers. Keep practicing, and soon you'll see that the names are not just words, they're blueprints of molecular structure. Until next class, keep spotting chemistry in your daily life, and remember, every name tells a story of structure and function.